Hi, and welcome to this review of sine. Today we're going to dig into what sine functions are all about, and take a look at 3 types of problems where you'll find it. First, let's look at the main use of trigonometric functions, which is to solve right triangles. Here's an example. Our goal is to find the measure of angle x. We know all the side lengths and know that there is a right angle which measures 90 degrees. But the other 2 angles are unknown. Because the sum of the interior angles of a triangle must add up to 180 degrees, we know that angle x and the other unknown angle must add up to 90, but we have no idea how they do so. They could both be 45 degrees, or one could be 50 and the other 40, or 30 and 60, and so on. There's no way for us to know unless we use a little bit of trigonometry, specifically sine. Sine, which is commonly abbreviated to Sin, is the ratio of the side opposite the angle we want to know over the hypotenuse of the right triangle. Remember that the hypotenuse is always the longest side and is always opposite the right angle, which is the largest angle in any right triangle. When dealing with trigonometric ratios, it's common to use SOHCAHTOA to help you remember them. The first part of it, SO, helps us remember that sine is the opposite over the hypotenuse. Because the hypotenuse will always be longer than the opposite side, this means the possible values for sine when used in a triangle like this are between 0 and 1. In our sample triangle, the side opposite angle x has a length of 12 and the hypotenuse has a length of 20. Now we know that the sine of x is equal to 0.6 when we convert the fraction to a decimal by dividing the numerator by the denominator. Now we need to use a calculator to find our angle. In the old days before calculators, this had to be done by looking through pages and pages of sine tables to find the value of sine x that corresponded to the measure of angle x. That still works, but it's easier on a calculator. First, find the sine button on your calculator. This button is usually used when you know the angle and you want to find the ratio of the opposite side to the hypotenuse. We want to do the opposite and find the angle from the ratio that we have already calculated, 0.6. So what we need is the arc sine, which is often labeled as a sine, or even more commonly as sine inverse, or sine to the negative 1 power. Note that the negative 1 exponent here does not represent the reciprocal, but the inverse operation of sine. This is accessed by hitting the second key and then the sine key. Okay, so we type in 0.6 and then second and then sine, and our calculator displays 36.86989, or approximately 36.87 degrees. We've done it. We can also use sine to find a missing side if we happen to know an angle of the triangle and the hypotenuse. Here's another sample problem. Okay, let's set up our equation. We know the angle is 30 degrees, so the left side of our equation is the sine of 30 degrees. This is set equal to the opposite side, which is x, over the hypotenuse, which is 14. The sine of 30 degrees is a number that we can find by using our calculator. We just type in 30 and hit the sine key, and we get a value of 0.5. So now our equation looks like this. To solve, we multiply both sides by 14, and we find that x has a value of 7. Success! Okay, so far we have used sine to find a missing angle and a missing side in a right triangle. What else is it used for? Our second use of sine is for graphing. Let's set up the simplest sine function. This is a sine wave. Its maximum y value is 1, and its minimum y value is negative 1. That's a bit different than in our triangle, where we couldn't have a negative value of the sine function, but that was because our opposite and hypotenuse sides were always positive. Let's look closely at the x values. Notice that these are not angle measures since there's no degree symbol on the numbers. Instead, we're using radians. You may have noticed that on your calculator you can choose between degrees and radians. Converting between radians and degrees requires you to know that pi radians equals 180 degrees. Look at our graph. Since pi is approximately 3.14, we can look just to the right of the 3 on our x-axis and see that the graph touches the x-axis right where pi is located. We can test this by making sure our calculator is in radian mode, RAD, hitting the pi key and then the sine key. We get a value of 0, which shows we interpreted that correctly. Let's try it again, but this time in degree mode, DEG. Let's use the equivalent of pi, which is 180 degrees. Make sure that your calculator is in degree mode, type in 180, and hit the sine key again. We get 0. The peak of the wave is halfway between 0 and pi, so if we are in radian mode, hit the pi key and divide by 2, and then hit the sine key, and we'll get a value of 1. The third place we'll see sine is when using trigonometric identities. There are a lot of trig identities, and they are used to simplify expressions or equations. It's kind of like a puzzle where you need to find the right identity so that you can substitute and simplify by canceling. Let's take a look at a relatively easy one. We haven't seen cosecant of x yet, but if we look it up, we find that it is equal to the hypotenuse over the opposite, or more usefully, the reciprocal of sine. Going back to our problem, we can substitute 1 over the sine of x for cosecant of x, which gives us this. And that's all there is to it. As you can see, sine comes in handy when graphing, solving problems with angles, and determining trigonometric identities. I hope this review was helpful. Thanks for watching and happy studying.